Hey everybody. In our last lesson we learned how to use the distributive property to simplify algebraic expressions, but in that lesson we only used positive numbers. Today we're going to introduce negative numbers into the distributive property and get some practice with it using those. Let's start by reviewing what we talked about last time. Remember, we talked about being able to express 4 times 29 using an area model. So instead of doing 4 times 29, we could break it into two rectangles. And we could do one rectangle was 4 by 20, and one rectangle was 4 by 9. And then we could find the area of each rectangle. 4 times 20 was 80, and 4 times 9 is 36. And then to find the total area, we could add these together. 80 plus 30 is 110, and we add 6, so the total area was 116, right? So we could really think about this as doing 4 times 20 plus 9, right? And getting 116 as our answer. Now, we could also think of 29 as, instead of 20 plus 9, we could think of it as 30 plus negative 1. So we'll have 4 times 30 plus negative 1. Okay, because 30 plus negative 1 is the same as 20 plus 9. They both give us 29. Now, I'm going to use my area model again to check this and see if we get the same answer. Are these going to be equivalent? So I have 4 as my width. Now, I have two rectangles. One rectangle is 30 for the length, and the other rectangle is going to be negative 1. Now, in the real world, we can't have a rectangle with a length of negative 1. But let's see if conceptually this works, if it gives us the right answer. Now, 4 times 30, 4 times 3 is 12. We add the 0, we get 120. 4 times negative 1 is negative 4. And remember, this little line here we treat as an addition sign. So I have 120 plus negative 4. That is going to give me 116, the exact same answer. We can do this with other expressions as well. 6 times 48 we can think of as 6 times 50 plus negative 2. So if we use our area model, we set up our rectangle. We have 6 as the width, and we have two rectangles. One is length 5, one is length negative 2. 6 times 50 is 300. 6 times negative 2 is negative 12. 300 plus negative 12 is going to be 288, right? And if we don't believe that, if we want to check that to make that true, we can check it on a calculator, and you will find 6 times 48 is 288. We can do 8 times 79. We'll do one more example here for the numbers. My width is 8, and I have two lengths, right? I can write 79 as 80 plus negative 1. So I'm going to have 80, and I'm going to have negative 1. 8 times 80, 640. 8 times negative 1 is negative 8. So my total, when I add those together, is 632. So we just did 8 times 79. That's a kind of a tough problem without needing a calculator by using the area method. We can use the same strategy when we have algebraic expressions with positive and negative numbers. Now, the first thing we want to do with these problems is make sure we rewrite it using only addition so we can clearly identify each term. So 4 times 5x minus 3, I'm going to rewrite this as 4 times 5x plus negative 3. And now we can clearly see that I have a positive 5x and I have a negative 3 inside the parentheses, right? This is similar to the step we did when we were combining like terms. Now I'm going to distribute. I'm going to set up my boxes for my area model. I'm going to label my width is 4. Now I have two rectangles. One of them is length 5x, and the other one has a length of negative 3. Remember, this doesn't really work in real life, but it helps us solve these problems. It helps us simplify these problems if we think about it this way. 4 times 5x, that's going to be 20x. 4 times negative 3 is negative 12. So now we can write our answer. We have 20x plus negative 12. And I want to simplify my signs if I can, and I do see I have plus negative 12. That's two symbols. We can rewrite that as minus 12. And now we only have one symbol to show that adding a negative. So this is the simplest version of that expression. Okay? Let's try this one right here. We got negative 3 times negative 8x minus 9. We're going to do the same thing because we have a subtraction that says minus 9. So I want to write that to make sure that we're only using addition for operations. So then that's going to be plus negative 9. Okay? So now I can draw my rectangles. My width for both of these now is going to be negative 3, so we have a negative width here. Negative 8x and negative 9 are my two rectangles up here, all negative numbers. So now we have negative 3 times negative 8x. That's going to be positive 24x. Negative 3 times negative 9 is positive 27. So my answer here is going to be, ooh, I messed up my color scheme. I'll go back to blue here. 24x plus 27. Now step 4, simplify my signs. I only have one sign here. It just says plus 27. There's really nothing to fix because I don't have any subtraction or any addition of negative numbers there. So I have 24x plus 27, and this is my final answer. I cannot simplify this expression anymore. All right, we're going to take a look at two more examples, and then we're going to wrap it up. For our first example here, negative 1 times negative 2x plus 7, I want to rewrite using only addition if necessary. Now, when I look inside my expression in the parentheses here, I just have plus 7. There aren't any subtraction signs I need to change, so I don't really need to rewrite this, actually. Right now, it would be unnecessary to rewrite that because I already have it as addition. So we're going to go straight to distributing. I'm going to create my boxes. My width is negative 1 this time, and my two lengths are negative 2x and positive 7 in this case. Now I can do my multiplication. Negative 1 times negative 2 is positive 2x. Negative 1 times 7 is negative 7. So my answer now is 2x plus negative 7. And I can simplify my signs. Instead of plus negative 7, I'll write minus 7. And there is my final answer. For this next example here, this one looks a little different. It says negative parentheses 5x minus 11. Whenever we have a number that's negative, we can think about it as being multiplied by negative 1, right? So instead of like negative 6, we could think of negative 6 as negative 1 times 6. And that's the same case here. So what I'm going to do is I'm going to write a 1 right here. So it becomes negative 1 times 5x minus 11. And that'll give us the same thing. So now this looks a lot like the example we just did. So I'm going to rewrite it using only addition. I got negative 1 times 5x. And instead of minus 11, I'm going to write plus negative 11. And now I can distribute. I'll write my box. We got negative 1 for the width, 5x, and negative 11. Negative 1 times 5x, that's negative 5x. Negative 1 times negative 11, positive 11. So my answer is negative 5x plus 11. And I don't have any signs I need to simplify here. So this is my final answer. All right, that's it for today. Make sure you complete your questions on your summary. Don't forget to submit, and I will see you guys in class.